So today I wanted to have a look at the iPACS Clinical and give you some outlook of recent developments that we had, as well as the roadmap going forward, showing you a couple of things that you might be interested in and just increasing some awareness of areas. We are moving more and more into the clinic, and security is a big part of this and a big deal, and we take this very seriously. As part of these efforts, our New Haven data center with our colleagues at M&I, as well as the Boston Software Development Lifecycle, have been SOC 2 Type 1 certified on the security trust principle. We finished that a couple of weeks ago, and we got audited by a CPA company called Kirkpatrick Price that's specializes in these security certifications. And the Type 2, or so the Type 1 certification is kind of a point in time that just reviewed all our documentation and policies we have and certified us that they are sufficient and effective. And for the end of the year, we are doing a so-called Type 2 certification, which where we additionally have to show a track record of at least 6 months that we actually do everything that we promise. So this is the Type 2 certification, which is our goal, is actually a pretty good indicator that that we know what we're doing and keeping your data safe. And from then on, our information security policy, as well as the SDLC, will be reviewed twice a year by an external auditor. And as part of this, also certified hosting in AWS, not only in the New Haven data center, is coming soon. If that's something you're interested in, please reach out to us. Another security-related feature that we're working on, and we are also already using internally and will become available with iPACS 2.0, is multi-factor authentication. So during login, iPACS so far just asks for username and passwords. However, passwords could get stolen or could get guessed, and a much better way to secure your iPACS is using multiple factors, something you know and something you own. In this case, what you own is your smartphone, that you just scan this QR code from an iPACS website during setup, and then you get a number, a 6-digit number that changes every 30 seconds. So if somebody tries to steal your account and they have your username and password, they still can't get in unless they also manage to get your access to your phone because of those transaction numbers here. And there are various configuration options. You can make this optional to whoever wants to opt in, or you can force this also based on roles. Like, for instance, require this for all admins and super users. And we highly recommend using multi-factor authentication in the future for all iPACSs that are publicly available. So if you have an iPACS that's just on-premise, locked behind your firewall, then you might or might not want to use it. But if you have an iPACS, for instance, to collaborate with outside partners, then the multi-factor authentication will be highly recommended. For convenience, devices like your browser you're working with every day can be remembered, so you don't have to go through the process multiple times a day, looking for your phone, opening the app. But let's say only every 14 days. We also put in some smart rules, like if you have some trusted networks, like your company network, you can also configure that they are opted out. And what I really like about multi-factor authentication is that it's effective and user-friendly, because I believe that we shouldn't fight users, for instance, with very frequent password rotation or very complex passwords, but we should come up with something smarter. Passwords are just not really made for users, because they're hard to remember but easy to guess for an attacker. Then coming to our software development lifecycle, and I just wanted to give you some overview of how do we do security testing. So we follow the so-called OWASP recommendations. That's the Open Web Application Security Protocol that came up with the most common threats, and they're giving recommendations of how you should train your people, as well as how you should implement things. And first of all, we try to develop iPACS with their security by design. For instance, we don't allow raw SQL, which is the language we communicate with the database, but we use some so-called object relational mapper in between to make sure that you can't inject SQL code into the application. If you're interested in this area, please ask for our iPACS security white paper. We have a document that describes all the design decisions that we have made for secure iPACS. We review critical areas of our code, for instance, related to authentication. We try to only use trusted algorithms. We don't try to outsmart smarter people than us that already invented and have proven algorithms by doing something on our own. And we do automated testing as part of our continuous integration. So for instance, if somebody makes a mistake and the authentication code gets bypassed, our automated tests would immediately tell us and show the developer that something is wrong. We also do a lot of manual release testing. We have full test protocols and test plans before an iPACS gets out to you as the end customer. And that's also a very important part. And then lastly, we are also scanning the iPACS and simulating attacks. There are softwares like Arachne or from Qualys that basically are like a spider that look at every function of the iPACS and try to fuzzy it with parameters, putting in things that are too long, too short, coming up with new things, and this way trying to find issues in the code, and then Eli and the team can dig in and try to figure out what went wrong here and fix it. One other thing that's really important also is configuration testing. That's also one of the OWASP recommendations, or one of the most frequent issues with web applications is that they're just configured wrongly. So one of the items we also do is we test our configuration. In this case, this is a so-called SSL report that looks at our configuration of our HTTPS website, and we get excellent ratings here. But you have to do this kind of after every change, because a small mistake could make the iPACS open to attackers that they could read a session. Otherwise, by default, iPACS is always, all communication with iPACS is fully encrypted with bank-level secure setup. Also related to security and ease of management is centralized user management. As you probably know, iPACS also has its own user database, so you can create users there, and they can have their own passwords, which is great in many cases. But if you're using iPACS in your enterprise, in a large company, then you should use the central user management via either Active Directory or LDAP servers. And iPACS will auto-create users that get authenticated with AD or LDAP. Something that's new in iPACS 2.0 is that we now support multiple Active Directory servers, which allows you to connect multiple sites or enterprises. There's a fallback. If one of the servers doesn't reply, it just tries the next one, so increasing the high availability. We can warn of expiring passwords. You can change your AD password from iPACS, and we also support the so-called AD Global Catalog, which makes iPACS use in large enterprises much easier. And we are using this, for instance, with our 3 sites in New Haven, Boston, London. They all have their own Active Directory tree that are part of a forest. Availability is also very important. How can you be confident that iPACS is always available? We have a solution for this that's called the Watchdog, that monitors one or multiple iPACS systems. Every 10 minutes they get queried how they are doing, and the iPACS then performs some basic function tests. For instance, the file system is checked. Is it available? Is it writable? And does it still have capacity? You get warnings if it runs out of space. Is the database alive and responding? The job queue that does the background processing, for instance, the reporting of reports that produce PowerPoints, as well as some other databases there. Are they still responsive? Are we current on our backup schedule? and things like this. And there's either a dashboard, as you can see this. That's how we use it, because we host about 45 iPACS systems for customers and have like 15 internal ones. Or you can get email notifications, or we also use Slack a lot for warnings, so that then the IT team can deal with the issue, preferably before the user even knows about it. The iPACS 2.01, that I will also go into the different versions in a later slide. This has just been fully validated, and that was a huge effort, but it's now fully validated for our New Haven core lab, which includes the submission module and the DICOM server that we have talked about in previous presentations. There was an extensive test plan, and the full installation and operational qualification was documented. We now have a strict change control policy, and the whole system is also integrated into a comprehensive data recovery plan. And that we have already, or iPACS is already used in many validated custom installations, but this was one of the bigger ones that we had to do. And we are also happy to help you if you are using iPACS in a validated environment. We're happy to help with these efforts. We already have a lot of templates and documentation that we can bring into this endeavor to do this together. One more issue that we are currently working on, we're already using this internally and will become available in the iteration or in the version after the next one, is deals with scalability of storage. So what we very often are faced with is that we have an on-premise iPACS with very expensive local storage that not only costs a lot, but also is hard to scale up with the needs of the scientists. However, while the local storage is expensive, it's convenient because you have all your data available at all times. And we started to connect iPACS with Amazon's Web Services Storage Gateway that combines the best of both worlds. Basically, you have a local cache on a server, typically in the order of 1 to 10 terabytes, with fast access to all the new files you do or everything that's frequently used. The computer figures that out automatically for you. And all the other files that are stored there get moved to Amazon's S3 service, which is their simple storage service, and allows you to offload all the data you currently don't need automatically into the cloud, fully encrypted and in a very safe way. However, the iPACS still thinks all the data is local. So if you're trying to access your files, they will be fetched automatically. There's then some latency. So if you're trying to access files that are remote, it will be a little slower depending on your internet connection. But you can just use the iPACS and it scales indefinitely. And I also made a small chart here. Not as big as the other ones, but basically we have an iPACS that's connected to a storage gateway, which then gives you as much storage as you need, and it can be connected either directly over the internet or in a virtual private cloud, depending on your requirements. So even for clinical data and in a HIPAA compliant way, it would be possible to do it this way. Yeah, I don't want to go into detail here, but Amazon S3 also has other, it's a very powerful infrastructure and allows you to define lifecycle rules of what should happen to your data. You can replicate data across regions, do snapshots of the server, all then integrated into the cloud infrastructure. And the cost is very hard to beat at $25 per terabyte per month. That is orders of magnitude lower than what you would have to pay for local storage. And there are additional options for infrequent access and Glacier to further reduce the cost. And one reason I really like S3 is the so-called durability, which is the chance that you lose an object within a year. And it's 11 nines. So out of a billion files, you would only lose one every 100 years. And that's also very hard to beat with any on-premise solutions, what they offer. So iPACS snapshots is another, that's one of the features that we'll see very soon in the next coming iPACS version, and allows you to travel back in iPACS time. Basically, on a per project level, you can just create a snapshot at any time, and it then stores the state of all your image browser data, your data points, as well as the web disk files and directories for that time point. And then you can go back in time whenever you want. There will also be a scheduling assistance that allows you to, for instance, do weekly snapshots. And this is an integral part of our GLP module, where it allows you to archive previous states of projects and be able to go back to this. And it's very convenient to use. There are reports integrated that show you exactly what were the changes. You can retrieve individual files, directory, and also the database data itself. So all the data points that you have created, for instance, with quantification data, you can always go back and restore the earlier state at any point in time. Then we have the clinical submission module that allows you to collect data from external submitters. We at Invicro use this a lot in our core lab, where we are working with 900 imaging centers all over the world and have to collect their data. And then there are configurable forms that you have to fill out, where you can ask for certain questions. Could be just what study is related to, but could also be some information about the patient's age, sex, or other details. And these forms are fully validated, so you can put in certain requirements for them. And then you can upload one or multiple studies. There are workflows for automatically flagging and rejecting, as well as automatic de-identification of PHI or PII in your DICOM data. Alternatively, you can also manipulate the DICOM header manually if you find something that you want to remove. And then mails get sent out to the sites, for instance, that their submission was accepted, as well as to the reviewers that something comes new in. And all of this can also feed into the iPACS workflow engine that I will show you a bit about later. So at the end of the submission, we have a QC module that allows you to see all the submissions that have been done. There's a PHI check that automatically pulls information out of the headers and highlights critical fields, and a very nice image preview that allows you to very quickly see if that data is actually what you're looking for. Like, is this a head MR, or was there wrong uploads in this? And from here you can then accept or reject the submissions, and there's a full audit trail that shows you who has done what with the data, and who has approved it or who has rejected it for what reason. So coming to the iPACS release schedule and outlook, we released the 2.01 version in August. That is the fully validated version that's available to all customers already. And the 2.02, which adds the snapshots, the GLP module, as well as the enhancements for Active Directory and multi-factor authentication, or two-factor authentication, that is currently in validation and should be available in October. And then 2.03 is the feature release that we're currently working on. It's scheduled for the first quarter 2018. And we are further increasing our focus on clinical workflows. We are trying to integrate even more with cloud infrastructure, for instance, for storage, as well as authentication, like single sign-on solutions. We are enhancement of messaging, trying to get more notifications of what's happening on the system, or what requires some input from users via Slack, email, Microsoft Teams, or text messages. We are further improving support for DICOM and in particular also non-DICOM image formats to treat non-DICOM images very similar to DICOM and extend them with meta information. And also together with our colleagues in New Haven, we are working on extended reporting, ETL solutions, data mining, and similar enhancements. And the 3.0 version will be the next bigger release that's currently scheduled for Q3 and is still in planning. I want to point you to two examples of tools that we're currently working on mainly for internal needs, but we actually think that they could also be of use for other iPACS users. One is the chemical compound database that we're currently setting up that allows you to put all your compounds in a table that you can query by certain meta information or images with an auditable record of what happens, and that links into the iPACS study planner, for which we will also have a talk later today. So if that's something you're interested in, get in touch with TJ or Bill to get a preview. And the other thing is, I mentioned this as the end of the submission workflow. The data comes in, and then we developed a workflow module that allows you to, for all images that you have in the system, develop tasks. You can define your own tasks. Could be something like image QC or analysis, processing, or passing on to radiologists. And all the images are then shown in one big one table that you can then query by what should be done as the next task or who's responsible for it. So you can filter by all kinds of different views. There is priorities for tasks as well as escalation. Like for instance, if a certain step wasn't done within 4 days, then a supervisor could get a notification that they have to step in. For instance, the responsible person is on vacation or wasn't in the office. And the iPACS workflow tool allows us to implement workflows directly integrated into iPACS from submission to reporting. So we always know what's happening to an image from A to Z. But you don't have to, have everything covered. You could also use it only for parts of workflows. Additionally, you can then later get some performance statistics and, for instance, see how long does it take for images to get from one state to the other, so you can find your bottlenecks and try to optimize. And full messaging capabilities means that it will, send you mails or Slack messages or similar notifications of what's happening, and so that people are always aware if something has been assigned to them that they are supposed to work on something. Great. So with this, any questions or comments?
Two-factor authentication as a security method. Are there any plans to integrate hardware tokens rather than software tokens like you would download to a phone? Because some companies would prefer that type of security measure not to be on a user's personal smartphone. Yeah, we're looking into integrating, for instance, with RSID, which we also use already ourselves. They're using the same protocols. As I mentioned, we are actually not trying to invent our own security protocols and algorithms. We're using a standard one, so it should be possible to integrate with hardware tokens for this. Great. Thank you.